ALE is a description logic designed to reason about concepts. In the following experiment, we focus on two types of assertions within this logic. A is a C, saying that element A satisfies concept C. So if A stands for Alice and C stands for comedian, then the assertion says that Alice is a comedian, which can be visualized like this. The other assertion type is A, B is an R, saying that elements A and B are related by relation R. So if B stands for Bob and R stands for roast, then this assertion says that Alice roasts Bob, which might look like this. We can make more complex concepts in a number of different ways. The first is negation, represented by the little hook symbol. Negation C means not C, or anything except C. So in our running example, the assertion means that Bob is not a comedian. Like this. We can make conjunctions, represented by the square-like symbol. C conjunction D means everything that is a C and a D. So if D stands for drummer, then A is a C conjunction D, means that Alice is both a comedian and a drummer. Also, there is the existential restriction, represented by the inverted letter E. This looks like a quantifier, but isn't. This assertion means that there is an element related to A by role R, and this element is a C. If it helps, one can think of it as a diamond from multimodal logic, indexed by R. Continuing our example, there is something which Alice roasts, and this something is a comedian. Lastly, there is the universal restriction, represented by the upside-down letter A. This again looks like a quantifier, but it isn't. The assertion means that for all elements that are related to A by R, all these elements are a C. Note that no such elements need to exist. If it helps, one can think of it as the box for multimodal logic, where the box is indexed by R. In our example, all things, if any, that Alice roasts are comedians. A set of assertions is called an ABox. Some ABoxes describe impossible scenarios. For example, this, where the first assertion claims the existence of something both related to A by R and not being a C, but the second assertion says that all things related to A by R are a C. In our example, the first assertion says that there is something that Alice roasts and this something is not a comedian. But the second assertion says that all things that Alice roasts are comedians. This is clearly an impossible situation, and such ABoxes are called inconsistent. If an ABox is not inconsistent, it is consistent, so it is either one of those two possibilities. This ABox is different from the previous one. The first assertion is the same, but the second one has a B instead of an A. These two different names, B and A, are assumed to refer to two different elements. As a result, this ABox is consistent. Likewise, this ABox is also consistent. Its second assertion has the role name S instead of the role name R, as previously. So different role names refer to different roles. That was all. In the following, it's your task to decide whether a given ABox is either consistent or inconsistent. Good luck.